the power rule for differentiation. We've just discussed finding the derivative of a function from first principles. And remember, always keep in mind that the derivative of a function is just the gradient at a particular point. It's the slope of the tangent line at a particular point. Well, if we go through that whole process of finding the limit as h goes to 0 of f of x plus h minus f of x all divided by h, we get the following results. For the function x to the fourth, we get 4x to the third. For x to the third, we get 3x squared. For x squared, we get 2x to the 1. For x to the 1, we get 1x to the 0. For x to the 0, we get 0x to the negative 1, which is, this 1x to 0 just goes to 1, and 0 times anything is 0. For this, we get negative 1x to the negative 2, which of course is negative 1 over x squared. And for x to the negative 2 power, we get negative 2x to the negative 3, which of course is negative 2 over x to the third. Well, we can find these all by taking the derivative from first principles. It's a long, drawn-out process, or we could just use this rule. The power rule for differentiation says if y is equal to x to the n, and n is an element of the real numbers, then the derivative dy dx, which, don't forget, is just the slope of the tangent at a particular point, or the gradient, dy dx is equal to nx to the n minus 1. In other words, we're going to take this n, move it out front, multiply by the x, and then subtract 1 from our power, or our exponent. An extension of the rule of the power rule for differentiation is if f of x maps onto a coefficient of a times x to the n, then our derivative f prime will be, well, we're going to multiply n times a, and then it'll be x to the n minus 1. So a x to the n goes to a n x to the n minus 1, and x to the n goes to n x to the n minus 1. This is a better one to remember because it's more inclusive. Look at the three ways we can talk about the derivative. The derivative meaning the slope of the tangent at a particular point. dy dx, y prime, or f dash of x. Okay, let's do some examples using the power rule to differentiate. Remember, that was if we have a x to the n, then the derivative became a n x to the n minus 1. That was our rule. Well, let's apply this rule. The derivative here would be 6x to the fifth. Here, we'd want to convert this to x to the power inside is 1, and the index is 3, so this becomes 1/3. So our derivative becomes, move that out front, x to the 1/3 minus 1, which we'll put as 3 over 3. So this becomes 1/3 x to the negative 2/3, and I would just leave it like that. Here we have 12 times 3 is 36, x to the 3 minus 1 is 2. Here, I probably want to write this as negative 4 times x to the negative 1. When I differentiate that, I'd have 4x to the negative 2. Here I have 2x to the 1 all divided by 7, and that's just fine. And this I could write as, well, this is really 1 over x to the 1/2, which is really x to the negative 1/2. So when I differentiate that, I get negative 1/2 x to the negative 1/2 minus, well, I have to minus 1, so I'll call that 2 over 2. So I get negative 1/2 x to the negative 1/2 minus 2 over 2 is negative 3 over 2. Please check your work with my work, please.